Okay, so I wanted to kind of start with this awesome picture, and hopefully most of you have experienced this personally when you've been on a slide or something, you go down it and your hair starts standing on end or something like that, or you've seen kids, your friends have been like that or something. So we want to kind of explain in this first part what's going on here and really kind of start introducing electricity. So we want to look at Electricity 101. Okay, so we're going to really kind of build up on the beginning and work our way through a lot of details. There's lots of information in this module. This module is going to be really important. Again, as I reiterated on the text of the module, the intro of the module that I typed, electricity is something that all of us use. Even if you're living off the grid, you still have to produce electricity somehow to charge your laptop, or if you're using a cell phone to charge your cell phone. Even if you're doing solar electricity, hydroelectricity, you're still using electricity. So it's something that all of us use. And the 2000s, 2020s, let's just be honest, we really depend on electricity. When the power goes out, people start to panic and so forth. So I really wanted to kind of go through and choose a first physical science module that we all could relate to and kind of go through with that. So we're going to do some things that you know. We're going to do some things that you're not quite sure about. But let's start at the very basics. So what is electricity? In layman's terms, it's the movement of charged particles. Now, specifically, we're going to focus on the movement of the electron. Electricity is really the flow of the electrons, but sometimes you can get protons moving. But we're really going to focus on the movement of the electrons. So, I want to say that because physicists initially thought it was the protons that move. So when I teach physics 2, either the trig based or the calculus based, where we look at circuits in detail and so forth, um, I have struggles when I should say my student. I don't have my students have struggles if they are electricians or if they've been in the military. They learn the conventional way of circuit flow based on the electrons moving, and in physics, we really have kind of not corrected ourselves, and we look at the flow direction based on the protons. We're not going to worry about that in this class, but some of you are engineering majors and stuff like that. So I just want to kind of reiterate that we're looking at the flow of the electrons that are moving. And just a reminder, what we're talking about, we have protons and neutrons and the nucleus of the atom. And then we have these electrons that are moving around. Now, I know the Bohr model is not correct. I can't draw the three-dimensional clouds, and we'll get more into this when we get into the chemistry module. So I want to go through and kind of just basically really focus. Electricity is that flow of charges. We've all heard electricity coming out of the walls. We know electricity is the lightning bolts. So what are these types of electricities that we want to look at? Really, there are really only two fundamental types. There's static, which is what we have here on the left-hand side. Static electricity, your hair standing on end and so forth. And then we have current electricity, and that's really the flow, the movement that we're talking about. So this is static electricity is being produced by two objects rubbing together. So the child's tush and legs sliding down the slide. I don't know if you did this, but I did this in elementary school, specifically if we had carpet in the wintertime. I grew up in the mountains and it was dry, so I would scuff my feet and you could go around and shock your friends. So my feet, as I'm going through, so if here's the floor, here's my feet, I would rub them back and forth, and what would happen is my feet or my shoes would actually kind of pick up the electrons from the floor. I would become charged, my body would become negatively charged, and then I would walk up to somebody and with my fingers sticking out, and they were usually sitting down, and you would touch them and you get shocked. I posted some videos where you can see in slow motion what happens when two fingers come together and you shock each other. It's a really awesome phenomenon to actually go through and see when you slow it down. So again, static electricity, when things are rubbing together, current electricity is really the flow of the electrons that are moving. So they're fundamentally different, but yet they're fundamentally the same. I mean, we're going to talk about different types of electricity. We'll talk about how electricity is produced by solar energy. We're going to talk about hydro. We'll talk about non-renewables like coal. We'll talk about nuclear. So we're going to talk about how the electricity can be produced, besides the point of walking around and scuffing your feet and touching things. We'll look at batteries. We're going to look at AC circuits coming out of the wall. So really, it's going to be a very busy module and a great way to jump into the course as we go through and look at different things. So next, what you're going to see will be a video where, as I told you, I wanted to show you a slow motion video of when two people shock each other with static electricity. And then we're going to get into, well, how do particles interact with each other? So we know we can shock each other, but what happens if you take a balloon and rub it with wool? So that's one of the activities I want you to do, is find a wool sock or someone that has a wool sock in your group or something, and rub a balloon with it. What happens to that balloon? How does it interact with other things? If you rub a second balloon, what happens to those two balloons when they come together? So I really want you to kind of go through and do some activities. I don't want you to get electrocuted, but these small shocks where you're going to see the static coming off. Unless it's really humid. If it's really dry, it's going to be awesome. You'll be able to see the static. And that's what happens with that. When you watch the video, it's a slow motion video. The car video that I introduced the module with, where the lady caught the gas on fire, basically what happened is when she got into the car and sat in her seat and rubbed her feet around on the floor, she charged herself, and basically she shocked the fumes coming out of the gas pump. And by shock, a flame and gas fumes are an explosion waiting to happen. So basically what happens is, instead of shocking her friend, like I would do here, she shocked the gas pump. So here's her car. She went to grab the nozzle. The fumes were coming out. She grabbed the nozzle, shocked the nozzle, or that handle, and that spark ignited all the fumes right there. So that's really, do not get back into your car while you're pumping gas. I don't care how cold it is or whatever. This could happen to anybody, and it actually happens quite more frequently than you want to think. As you get back in your car, you build off static. Because think about it, how many times have you gotten in your car and you get out and you shock the car handle? You're rubbing around in the seats. Your feet are rubbing on the floor. Most of you have carpeted floor or cloth seats. So you're rubbing around, and basically you are charging yourself just like this kid did going down the slide. So again, in the next video, we're going to look at how these forces interact with each other, why the balloons are doing what they're doing. So go ahead and try that activity and then come back and start looking at some more videos.